6-5, here we go. Number 28 was asking for magnitude and direction. You guys were hopefully using Pythagorean theorem with A and with B. B was a negative sign. Yes. Pythagorean theorem, solve for magnitude, tangent inverse of B over A. Now they wrote this whole snazzy thing. That definitely should not be in any of your papers because we just said use tan inverse and then think about where it ends up and whether or not it makes sense. This one, if we were to graph it, isn't the x positive and the y negative? Doesn't that mean it's down here in this quadrant somewhere?
Yeah.
So, when you did tan inverse and got a negative angle, would you have been in the right place? Yes. So what they say, they said, no, we like the positive angle. Okay, fine. So then what do you have to add to the negative angle? 2 pi. So that works, you just add 2 pi. And you should have gotten the 5.26, that's in radians, not degrees, right? So you might have a negative angle, and that doesn't mean you're wrong, but just a quick heads up, even on the multiple choice on the test, they're gonna like the positive angle. So if it is truly in the fourth quadrant, which this one is, positive x, negative y, the negative angle needs to add 2 pi to make it the positive angle that they prefer. Does that make sense? Okay. 1, 2, 3, 4. 5. Struggle. Tomorrow's a test and we have 5 people that did not even touch this homework. That's awkward. Alright. Then if you were to graph, you have it in the fourth quadrant. Number 70. What theorem? Whoa, did I only give you guys? Whoa, how many evens did I give you? 1, 2. What do you think I wanted you to be able to do?
Check your work.
Check the work and come today with questions for our work day.
One test because we wanted it was like for number 28.
In the multiple choice, it'll have the positive.
It's the same
Just beware. I don't want you guys to be like always add 2 pi if it's negative. What if it was a negative x and a positive y? You wouldn't be adding 2 pi. You'd be adding pi. Yeah. So I would just say get the picture of the vector. It's a complex number, and just make the angle right.
We can get that
Yeah.
pi.
Huh?
Oh, yeah.
If it was over here.
Okay.
If it was a negative and a positive, you would still get this angle from your calculator. You would need to add pi. So get a picture. Remember, tangent inverse. There's warnings all over our notes. Warnings all over our notes. Number 70, what theorem did you guys use? De Moivre's, good. And De Moivre said raise the r to the power, so that's why, ooh, hold on, we have to get the r first, right? How'd you guys get r? There's 2 ways to do it. If you want to be super creative, you could say, wait, 1 and root 3 aren't in the unit circle. If I divide by 2, that's in the unit circle. You could have done something like that if the 2 can actually show up. You guys know that I use my marker in Microsoft Word. So you could have divided by 2, and if you divided by 2, this would have ended up being 8. I know it's weird. You could have made this 4 times 2 over 2 and combined and then brought in, hey, there's my sine, and here's my cosine. If cosine's positive and sine is negative, it must have been 5 pi over 3. And 8 must be my r. Anyway, that would get pretty creative though. And for most of you, that's not a good idea. So let's use our formulas. How do you find r with an a and a b? Pythagorean theorem. Square root of 1 squared plus root of 3 squared is going to be 2. How do we get theta? Tan inverse of b over a, which is going to be negative square root of 3. And tan inverse tangent is square root of 3 over 3, 1 square root of 3. So I need a square root of 3. Sorry, I need a pi over 3. I need a 60-degree angle. And how did they know to put it in the fourth quadrant? X's was positive. X's were positive. The x was positive. The y was negative. Fourth quadrant, so that's why they chose 5 pi over 3. Pi over 3 would have been wrong. 2 pi over 3 would have been wrong. 4 pi over 3 would have been wrong. But we needed 5 pi over 3 because that matches up with the positive x. And then the name of the game was, okay, because I have this cube, I need to go ahead and cube the r, multiply the angles by 3, and then they said standard form. So did they stop there? No. They simplified. What's cosine of 5 pi, which is the same thing as cosine of 1 pi? 0. And what's sine of, oh, careful, no, cosine is negative 1. at pi. Sine is 0. That's why the i's are all gone. That's just -1. -1 times 4 times 8 is -32. Dun, 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 dun. Not very enthusiastic. Okay. Questions on odds? The ones you were able to check. Questions on odds, the ones you were able to check. Yeah, Ryan?
Well, 83 and 89 are, so I guess 89.
Does anybody have a preference over 83 and 89?
89.
Okay. Hey, look, the book is working. Why is 89 especially weird?
Doesn't give you anything else.
It's just 16. Where's the I, right? Well, how do you write it as a complex number if it just gives you 16?
Zeros.
Joe and Carl, especially since one of you didn't have any homework. Number 89, there is no I. So I make it 16 plus complex number is a plus bi, so I need to go ahead and make it 16 plus 0i, yeah? So if I make it 16 plus 0i, let me get a single page so we can just look at it. Let me zoom in so we have room. Oops, that didn't work. The goal was to, on number 89, find the fourth root, right? Is complex because it can be rewritten as a plus bi. True? So here's the weird thing. How many fourth roots of 16 are there? Most of you guys would say 2. Positive 2 and negative 2, right? 2 times 2 times 2 times 2, 16. Most of you would say fourth roots of 16 plus or minus 2. Problem is, how many roots are there supposed to be? 4. Ooh. It means 2 are imaginary. How would I ever find them? Using the complex number form. Using the complex number form, I can say, okay, I need z to be in r cis theta form, or r cosine theta plus I sine theta. The nice thing is r is pretty easy, because r is equal to the square root of 16 squared plus 0 squared. Isn't that just 16? The 0 doesn't really change anything. Cosine of, I'm going to have to find beta using tangent inverse. Calculators, degree mode, make sure they're in degree mode for tomorrow unless there's something funny in radians. Bless you. Tangent inverse of who over who? You either have 16 or 0, and it's always b over a, right? So b would be
0.
A would be. So when is tangent 0? At 0. Is that it? No. It's 0 a lot more places too. It's 0 at 0, and it's 0 at pi, and 2 pi, and 3 pi, and 4 pi, and 5 pi. I'm just going to write a few of them. Okay, so we have cosine of angle plus I sine of angle. Hold on. Even though it's 0 and pi and 2 pi, why do I have to say wait? Hold on. Why do I have to take away the pi's and say no, they don't belong? Why am I just going to say 0 and 2 pi and 4 pi, etc.? What happened to the odd ones? If I graphed it, wouldn't it be right here? I'm not over there. I'm over here. Does that make sense? What would this one have to be? Negative 16. It's positive 16. All right. What does De Moivre's theorem say if I want to find the fourth root? Fourth root of r, then divide by 4. So what do I got? The fourth root is the same thing as, the fourth power is the same thing as the fourth root, right? Of 16, which is going to end up being 2. And I'm going to have, can I just use the cis notation just to be lazy? Cosine theta plus I sine theta. 0 over 4.
0.
That works. 2 pi over 4. I'm going to keep on going until I finish one full revolution. 4 over 4 would be pi.
8
What would the next one be?
8 pi over 2.
What would the next one be?
2 pi.
Ooh, too big. Because 2 pi, we go back to the beginning and it'll just hit in the same exact place. So we end up as our fourth root, so if you were to graph it, it would be 1, 2, 1, 2, 1, 2, 1, 2. That guy, that guy, that guy. There's the graphs of all 4 of my fourth roots. If they wanted standard form, I could go ahead and simplify. Ryan, you had that question. Did it say write it in standard form?
I didn't read the question.
Did you have it, Patricia? Yeah. Oh, okay, then we have to actually solve for stuff. That's okay. What's cosine of 0? Cosine of 0, not negative 1. It's that way. Positive 1. So we're going to end up with 2 times positive 1 plus sine of 0 is 0, right? Which is just going to end up being 2. Then I have 2 cosine of pi over 2. 0. Plus sine, that'd be 1 times I.
2i.
Then I have cosine of pi, there's your negative 1. Sine is 0. You guys see the pattern, right? Yeah.
So we're just gonna put 2
It's plus or minus 2,
Yeah,
plus or minus 2.
To show what
Well, you put all your pennies on not being a long answer.
Make it look like it's something.
Wait, when you find the 16 to the power of 1/4, don't you need to find 4? Because the fourth root of 16 is 4 answers.
That is fine. Yeah, that's plus or
When
minus.
you're raising r to the 1/4 power, you're not considering it as a complex number. I mean, this whole thing is considering it as a complex number. So when you're raising r to the 1/4, you're thinking of the real solution. And you're not solving for it, you're being given it, so that's not even the plus or minus. Plus or minus is if you would have z to the 4th equals, and you would take the 4th root of, and so that would allow for the plus or minus. But when it says find z to the 1/4, it's already been established to just be the positive, and it's already been established to be the real. But when you were given the directions up here, the 4th root of, or the 4th roots of 16, the struggle is they were indicating that they wanted you to find all possible roots, real and complex. I should say real and imaginary. So all the complex roots. Does that kind of make sense?
Yeah.
Ryan, does that kind of answer your question as to the process?
Yeah.
So you would find the r first from the original problem. You would find the r by doing Pythagorean theorem to get, to get the r to put into the r spot. You would do tangent inverse of b over a to get to the angle and put that in the angle spot. If it is a 4th root, you have to put multiple angles because we're looking for 4 answers total. When we go to divide, what normally would have been too big, 2 pi would have been too big, but when we cut it in 4ths, well, all of a sudden it's fitting right where I need it to be. So that's why there's additional angles. Our book says something like probably plus 2 pi n or plus 2 pi k. I just list them all out. It makes it nice and easy, and I know when to stop when I'm doing my division. Then I just apply the theorem. Okay. That's number 89, and that was the last hand that I saw on section 6.5. Kiddos, you do have test review. And today is basically a work period. As you guys are getting ready for that, in the sense of maybe turning in your homework spiral to the test review and writing it down because you didn't start it last night, or you're opening up to what you've already started. Question real quick. Has anybody started and gotten stuck on anything yet that they would like to ask? Okay. Chapter 6, let's recap real quick what's on the test. We started off with lob sines, lob cosines, true?
Yeah.
Okay. Do we have 2 area formulas that go along with those? Yes. Then we got into section 6.3, which was everything to do with vectors. How to write them, how to find magnitude and direction of them, how to add them, how to get them into components to add them to make life so much easier, how to find, we already said magnitude and direction. Section 6.4 said, ooh, there's this thing called a dot product, and it's used in all sorts of different ways. And then 6.5 says, how is this section? Complex numbers. A lot of the math from vectors apply to the complex number stuff. Before I have you guys just totally start a work period, one more time, are there any specific review questions? We have questions on the act. Okay. You guys will let me know if you get stuck on something you can ask me. Okay. Let's talk about the test real quick. If you want to get into your notes to write some stuff down, that might be a good idea. If you want to write it on your test review page, because then you're using it as you're reviewing, that might be a good idea as well. Hey, bring your calculator. I am not going to let anyone who forgot their calculator borrow one, and it would be a very sad test without it. So please bring your calculator. You're going to have to use the law of sines. You're going to have to use the law of cosines. You're going to have to solve some basic word problems in the multiple choice. Maybe some little harder word problems. You're going to have to solve for area at least 2 different times with 2 different formulas. That should tell you both of them are important. Ooh, here's something random you might want to write down. How to find a unit vector, totally in our notes and in homework. A unit vector would be a great thing to look at. Quick reminder, when you guys go to find the direction of a vector or a complex number, can you just type in tan inverse and be done every time? Draw a picture, make the angle right, correct, in the right place, in the right quadrant, okay? Just like what David and I were talking about a second ago. The component formulas for vectors could be very helpful. Isn't that the whole magnitude cosine angle? Magnitude sine angle thing? Dot product, that's pretty good too. Dot product is pretty good too. Otherwise, complex numbers, how to graph them, the difference between standard form and trig form, and how to go back and forth if you need to. Ooh, something to do with work. That was a thing. Some long answer to do with work, and some long answer to do with something on an incline. Man, I'm something to do with work. I'll give you guys the whole test. And something to do with incline. Now kiddos, listen very carefully. Have your calculator tomorrow. True. There's one more thing that you need besides the normal notes, homework spirals ready to go, blank piece of paper. Definitely have that in case you need scratch paper, okay? Blank piece of paper and cover sheet. Pencil with eraser. Did I say calculator? Okay. All right, there's some tricky formulas in, listen, section 6.4 and 6.5.
Yes.
6.4 has projection and work and dot product and orthogonality of vectors, and 6.5 has de Moivre's theorem and all the others. You are allowed on, let's just say like on a blank piece of paper, you're allowed to write down any and all formulas that are introduced in sections 6.4 and 6.5 only. What does that mean? You have to know law of sines, law of cosines, the 2 area formulas, and the basic vector formulas. But all the ones that show up, bless you, in 6.4 and 6.5, as long as you have them written on a piece of paper, and you're going to have your blank piece of paper also, so have the one with the formulas and the one that's blank, have both of those to use as cover sheets, work papers, etc. I will check them really quickly before the test and we can go. I would like to start the test ASAP tomorrow. Sound good? And if you're like I usually go long on tests, you might want to bring your books for the next period. That way you don't have to go back to your locker. Because for me, all you need is notes and homework spiral. Sound good? Okay. As soon as you get in here tomorrow, just to save time, as soon as you get in here tomorrow, you can go ahead and turn your notes on the front table. Homework spirals back by Eileen. Sound good? Notes up for me to write. Note. Homework spirals back for Eileen to go. Get out your piece of paper, pencil, calculator, and actually tomorrow I'm not going to be handing out the test based on rows and based on everyone being ready. I'm going to hand it out based on you being ready. So as soon as your desk is clear, your 2 things are turned in, blank piece of paper and calculator, show me your formula, sweet, go. Sound good? Any quick questions, Jeff?
Do kids usually do well on this test?
if they know the formulas and how to use them, yeah. But if they're like, oh, homework was fairly easy because I could just look at the formulas the whole time, or if they just say, I give up but I'm not willing to even try. So it depends.
Oh wait, can we write the name of the formulas on the?
Yeah, that's okay. Anything 6, 4, 6, 5 introduced there. So go writing the like, ooh, magnitude cosine theta from 6, 3. Unless maybe there's some way to write it for the 6, 5 one, you can kind of use it for the 6, 3. Just make sure it's in the right notation. You can't have the magnitude, but it can have our cosine theta. 6, 4, and 6, 5, any formulas introduced in our notes or the book in 6, 4, and 6, 5. Ready, set, work? You want to put in music? Put in music. If you want to move around, move around. You have a question for me? Zoom, zoom. Good time. Good time. Music up.
Break the ground. God, how did you do there?
Sorry, why are you blowing your nose like every 10 minutes?
I have no idea. I'll do things also.
Stop the recording.